Hello, hello. Cool. Right. Welcome to the panel on rollups design from off-chain to on-chain. In the panel we have people from Arbitrum, Scroll, Nethermind-Starknet, and Taiko, but I'll let them introduce themselves, so let's have a quick round of introductions.
Hi everyone, my name is Keng from Taiko. So Taiko is a type 1 ZK EVM.
Hey, my name is Jorik. I'm co-CTO at Nethermind, and I mostly lead the Starknet related developments there.
Hello everyone, this is Mohammad. I'm from Scroll. I'm a protocol researcher at Scroll, and you guys probably know Scroll.
Hi guys, my name is McCorry. I'm a researcher at the Arbitrum Foundation.
Right. So in the description and in the panel topic, we called something rollups. Can we have each one of you define rollups in 2 sentences?
Okay, so I think a very Eli 5 explanation of what a rollup is you put transactions onto a transaction. you put multiple transactions into one transaction on L1. Yeah, and this allows your transactions on the L2 to be basically.
Maybe a very succinct version would be Ethereum security inherited computation scalars.
You guys are very cryptic. I define rollups as pushing execution off-chain while keeping security same as L1.
Awesome. Actually, I think defining a rollup is very controversial if you don't remember all those blog posts about what is a rollup, what is actually a rollup, what is actually a rollup. I think that strictly a rollup is just where you take data and you post it to Ethereum. I think that's the strictest definition, but I think there's a much more easier way to explain it. So who lost money at FTX? Maybe I'll start off with that. There you go. I'm so sorry for that, by the way.
Can you speak closer to that?
Oh, sorry. I'm sorry for that. I know that great house in the Bahamas. But the point is, the whole point of a rollup is, could you have an experience like FTX without having to trust the system operator? You know, can I lock my money in? Can I transact, bring my money back out, but never trust the operator of my funds? But still have that same user experience. That's the goal of a rollup.
Cool. So we understand that rollups are something that puts data onto L1. Now, moving on to someone who must be responsible for posting this data, and there's a few designs out there in the space called proof of governance, proof of stake. Could I get all of your takes on the difference between them and what is actually proof of governance?
Can I pass it?
Yeah, sure. Proof of governance is kind of a more recent idea here, where you're saying that the operator set that's actually in the network doesn't necessarily need to be governed by a proof of stake, or may not necessarily be permissionless in a strict sense. Instead, is run by the governance of the L1 contract. And to explain that a little more, the reason is like a special case here is because all of the rollups rely on a smart contract which is posted to Ethereum. And if you want to update the way that the rollup works, you need to update this contract. And this causes a lot of sticky issues in rollup design, because it's not just the case that the entire network can come to consensus and change the operation, they also need to change its contract. So they should also be able to sign a multi-sig or have some other way of mutating the contents of this contract. And then it becomes a question of, is it the operator set that has the control over this contract, or is it some broader social governance that has control over this smart contract? And proof of governance says if you have broader control over this contract, then maybe that broader control should also have control over who the validators are. I think it's quite controversial actually. And it depends on whether or not you want to come to consensus, or if you're a base rollup, or if you have proof of stake and so on. I'll pass this on.
Very good explanation. So I think proof of governance is basically adopting the way governments work, like the way governments work. We have elected officials who are elected somehow by stakeholders, and they govern the thing. And if we adopt that for like controlling updates of the as a rollup a smart contract, we are susceptible to the risks that already threaten us in our real life, that prompted us to build this Web3 thingy. So that's quite bad. But still, people are thinking about layered proof of governance, like we have a set of governors who make most of decisions, but if they want to go rogue and do something bad, probably we need a mechanism to stop them. And people have proposed mechanism as crazy as this one. Like maybe we have a decentralized ID, and people with decentralized ID can vote, so one person, one vote, and stop this governance if it's going to do something controversial, suspicious, or bad. So that could work, but I mean it relies on a very strong primitive, which is decentralized ID, and God knows when we get that.
I can jump in. I think for that type of question is always worth dropping back a bit to wonder like why we even need proof of stake or proof of governance. So when you think of a rollup system, a rollup is basically just a database. You know, it has account balances, program states, smart contracts, everything. Then the question is, who is the actor that can order transactions, and who is the actor who can execute those transactions and actually update the database? So we call the actor who can order the transactions a sequencer. I'm sure everyone here has probably heard of the sequencer before. Then the executor could generally be one honest party who will pick up those transactions. They're already ordered, so they just execute it. Then they convince this smart contract, this is what the database looks like. Maybe that's a zero knowledge proof, maybe that's they're going to attest to the state, then it could trigger a fraud proof, etc. So now that you have these sequencers and these executors, you need to basically decide how do they get appointed. Why are they the privileged actors that can actually order transactions and update the system? And that's not actually a new problem. We've already had that for like 14 years with proof of work. You know, the whole point of mining is to elect someone to get the authority to create a block. It could be proof of stake. I put my own money in the game. I self-appoint myself. And I give myself the authority to actually do this work. And then proof of governance is this idea where what if you could have the token holders of the system elect and vote for someone to take on that role? So they're appointed. And that's basically the difference. And obviously they all come with their own trade-offs. You know, proof of work's bad for the environment, as you mentioned, for, you know, allowing voters to be, vote for or appoint people. That's a bit like democracy and governance, and that can be a messy world. And of course, proof of stake, you like to think that could be slashed depending on how the system's designed. A lot of proof of stake systems have to be slashed as well, so probably not also a great solution.
Yeah, I think in terms of Taiko's context, proof of governance could be something like a part of our multi-proof system. For example, our token holders could veto a particular proof that we might think that is wrong, a particular validity proof that might be buggy, because we don't know in this, like in the current state of ZK proofs, we can't be for certain that they are 100% bug free. So if we need to have like a kill switch, then we need like this proof of governance. We need we need an alternative proof system to prove blocks, I would say. And for proof of stake, we actually tested this out in our previous testnet, Taiko testnet, where we used a proof of stake mechanism to select provers to prove blocks on Taiko L2. And this could also probably be applied for proposers, decentralized proposers on L2s, where they have to stake something, they have to stake tokens in order to propose a block. And perhaps if they do not propose a valid block, their stake will get slashed. Yeah.
I think everyone said very good things. Patrick made a very good summary. I think one thing that's important to say for people who were not following the discussion around this is that the problem with proof of stake and why you are not just doing proof of stake is that, initially it sounds interesting because you stake and if you do something bad you get a slash, so it sounds perfect. But the problem is we have these derivatives like liquid staking and however you do your staking, these derivatives will show up, and you end up with a situation that the capital is abstracted away. Like the people who have the money and stake are a separate set from the ones who are doing the operation. And as operator, the only thing that you have to lose is your legitimacy. And when the only thing that you have to lose is legitimacy, why not do proof of governance? Like it's the same. So that's the narrative that prompted proof of governance.
Thank thank you for summarizing the difference between proof of governance and proof of stake for us. Moving on to a bit more different topic but similar in spirit, is there's a sequencer whose job is to sequence. Does a rollup need a sequencer of its own? Can it borrow sequences from L1? Can it make its own sequencers? Can the users of this rollup directly go to L1 itself? How does that look like in different designs in the rollup space?
So I actually don't know what a sequencer is because Taiko doesn't use a centralized sequencer. So we have like a decentralized sequencer. So anyone can actually propose a block on Taiko. Yeah, but I guess in the context of other rollups, you probably need a sequencer to propose a block. Yeah, maybe you guys can elaborate on that.
Well, as far as I understand, Taiko is based, right? So
Yeah.
To explain this to people means anyone can propose what the next block is, and they just need to submit a valid transaction on Ethereum to include those set of transactions, right? This makes it completely permissionless. It's a very interesting design, I think, because it does solve a lot of the complexities around the other rollups. I've also been recently thinking about something called dank rollups, which is you do the same thing but put it into 4 just to keep it cheaper. But in Starknet we've got a centralized sequencer because the whole intention here is to go as quickly as possible. So they make this trade-off saying that why does the rollup provide scalability? Because it's not as decentralized as Ethereum. And it doesn't need to be constrained by the same things as Ethereum. So it can be bigger servers, smaller set of people, and then therefore big server goes fast, right? I think this makes a lot of sense as a design. But you still need to trust this one user, and so you tend to need something like a soft finality that's already, I think Swapnil has more questions about that later, so I'll pass on.
Yeah, I have a lot to say about this topic, but I try to be brief. So there are the approach that Taiko is taking, the base rollup approach, is very satisfying. Like, it's theoretically very satisfying. It makes everything clean. If L1 reorgs, it doesn't matter. If you want to do cross communication between different rollups, it's easy. Everything is easy. I mean, it's very clean. The problem is you lose a lot of things that a centralized sequencer can offer. As was mentioned, like we already have security. The only worry is liveness, and users' funds are safe, especially with ZK rollup. So we don't need to have that level of decentralization. And if we do with the base rollup approach, like, you have to wait for the proof at least, and you don't get confirmation. And maybe you have to wait for a big block to be created, then submitted on chain, and a user has to wait like for 5-6 minutes to make sure that even his transaction is included in a on-chain batch of transaction. So not too fast confirmation, which you can get from centralized sequencers very easily. Besides that, there are a few problems, especially when you want to optimize the cost of your data availability. There are a number of ideas for compressing transactions before sending them on chain, like removing signatures, removing nonce, mapping addresses to indices, and stuff like that. That are already done by ZK Sync and or even just submitting a state diff. And basically, if you do that, and you are the sequencer and the prover at the same time, it's okay, because you already have the witness data. You can provide those things inside the circuit, inside the proof, and they get validated. But if we do the base rollup approach or any approach that separates sequencer from prover, then you can't use those optimizations. So it makes the a lot of optimizations around DA compression more complex. But that's it for now.
Yeah, I give a little bit of historical context to this as well. So Arbitrum was originally technically a base rollup back in 2020. That was before I joined the team. And I remember when I saw their design, I pinged Ed it on. I'm like, guys, you're crazy. Why are you doing this for? Like, why would you remove the one thing that makes the rollup so exciting and easy to do? But what you get out of that, like when you see the base design, see centralized sequencers, see these committees, what it really highlights is that the sequencer is an optional role. It doesn't actually have to be there. And it's very different. So when people look at layer 2s, they always think the layer 1 mindset, and so the kitchen sink in layer 2, think layer 2 has to look like layer 1. But they're very different setups. In layer 1, you have to assume an honest majority of the stakers. So in Ethereum, you want to maximize who can participate because you need an honest majority. In a layer 2, you need one honest party. One honest party to produce the proof, one honest party to trigger the fraud proof, and and that's like the safety of the system. The liveness is you just need a way to order the transactions. And so the goal isn't really about like who your sequencer is or who your sequencer is not. It's really about what is your transaction ordering policy, and how do you go about trying to enforce that. Do you want first come, first serve? Do you want the hash to be first? Maybe the most MEV extracted transaction should be ordered first. Like, what's your ordering policy, and how does your protocol allow you to enable that? And so that maybe maybe for first come, first serve, maybe it's easy to have a centralized sequencer because if they break the rule, you can just kick them out. Maybe you need a committee, and then you have this special protocol where they can't observe the transaction until after it's ordered, which I think first come, first serve ordering. But that's what you should really care about, not really whether there's one or two or many different sequencers. Just what is your ordering policy, and how do you enforce that? Because that's what users will care about in the end.
So jumping off Patrick's last question is, the rollup should enforce sequencing policy, and someone should enforce it. Proof of stake and proof of governance or decentralization seems one design to enforce this policy. Are there any other current designs in the space to enforce this kind of policy, apart from centralized sequences?
Yeah, so like maybe going back to the base rollup, we have like a decentralized sequence of decentralized proposer mechanism, and this actually allows for actually like decentralized MEV extraction as well, because since anyone can propose a block, it means that anyone can order like transactions on L2 and submit them to L1, and this is pretty powerful because we are able to tap on existing protocols out there, like existing block builder protocols out there to extract MEV on L2. I think.
Can I add one thing? Yeah, sure. The problem with that is you're flowing all that value to L1 proposers. L2 doesn't accrue, L2 don't get any of that value. Like the proposer, the L1 proposer in which this transaction of base rollup is included is going to get all the value from the builders who are sending the transaction. Not that this is something bad. It's very ETH aligned. I like that. But you don't get any money, or provers don't get any money, so your network doesn't get any money. But yeah, I mean, it's an interesting design.
Maybe I can just defend this statement. So the prover actually can receive part of the MEV share because in our A5, our latest testnet design, we implemented this prover market where the proposer can actually pay ETH fee to a prover. So that payment can actually be part of the MEV share.
That would work, yeah.
What was the question again? Sorry, I just got caught up in the spiciness there.
Are there any ways, apart from decentralizing my sequencer set, to enforce the policy that I've chosen for my rollup?
Yeah, I mean, it really just comes down to your policy. I mean, so let's just say it was first come, first serve. That's the ordering policy you want to enforce. The simplest way today is, the sequencers are black box, and if you suspect they're doing MEV, because you start getting on-chain evidence, you use proof of governance and you kick them out. That's how a lot of these rollups work today, especially Arbitrum. I know for that one, and one of the offers is sitting over there, Akaki, he's working on a proposal called Time Boost, where you basically set up a committee of sequencers, and then they'll get like this blob, and then they'll order it, and then it pops up the other end. But there you need a committee to enforce first come, first serve, and that comes with a lot of very interesting nuances around that as well. Because actually trying to order first come, first, guaranteed first come, first serve is very difficult. If you have an ordering policy where it's maximally enable PBS to its maximum extent, then maybe what you'd want is we want like a base roll up where you have the builders and basically the proposers. Maybe you'd want something like that set up. So it just depends on what your goal is, and then you'd have to construct a protocol to achieve that. But that's a huge space to be explored.
I think a quite simple answer here as well is you can try you try asking how do you select the set that is going to be decentralized or different ways.
I'm asking even more abstract.
Yeah.
Is a decentralized sequencer set the only way to enforce policy? So there's a centralized sequencer set which is just says you're doing it right, Are there other ways, some cryptographic protocols, some commit release scheme? I'm just asking the questions.
Questioning the fundamentals of Rollups here. I'm actually not aware of any of this. Yeah. But I want to plug some choices here. Like you don't need to rely on your own state. Like you can use eigenlayers set in, but that's not related. But yeah, we can move on.
Kind of alluded to my next question. So we have this idea of that we want to have an ordering policy and someone enforcing it. What is my incentive to enforce this policy? Why would I want to do this for you? And also, tag on question, should the users get a choice in expressing this policy, or does the Rollup designer, is it only the Rollup designer that gets to choose this policy? Can the user send their transaction and their ordering policy, and then the Rollup has to play a massive order book?
Maybe start with Patrick.
You get the hard questions.
I mean, there's two set of questions there. One is, how do you guarantee this ordering policy is actually enforced? And I think it comes down to your assumption of how do they get evicted if they don't do it. If you assume that there is a totally rational protocol and there's no way to evict a party, it's very difficult to not appoint them, then you really need a cryptographic protocol to enforce it. You really need to tie their hands, so that's the only thing they can do. Today, none of those protocols are implemented, so we have the weaker assumption that we assume they're honest, but we can get evidence if they're misbehaving, and then you vote them out and you just evict them. It's a much more cozy or nice assumption that we have. Allowing users to decide their ordering policy that the sequencer would use, I'm not giving that too much thought, to be honest. I think that's a tricky one, isn't it? Because really the ordering policy is up to the sequencer. It's not really up to the user. Like if I send it to the sequencer to say, well, maybe one thing you could do is, so we're not really about like first come, what you could do is say, should I allow this transaction to be entered into like an MEV competition, for example? You could have like optionality around that. And that brings it to another point where the sequence, what's unique about Rollups is that, well, not unique necessarily, but what's nice is because the sequencer can take these transactions and hold them for a long period of time, they do have a great opportunity for MEV extraction for per se, or also just to inspect these transactions. So what they can also do is enforce ordering policies where they only allow good MEV, like back running or maybe just-in-time transaction, just-in-time liquidity sandwiching, but they don't allow bad sandwiches or front running or etc. So there's a whole space there of, can we be subjective over how which transactions are included to the betterment of the user? So maybe that's like a Taiko, but I've not really considered can the user decide the ordering policy. That could be interesting to explore, I don't know.
I want to add some more. About ordering policy, I'm not really a huge fan of ordering policies. Like, I don't think if it's going to maximize social welfare and it's economically efficient if we do that. And we could extract that value and give it back to users. Why just throw that away? While I truly believe that Arbitrum wants to be credibly neutral with first come, first serve kind of approach, but people can find Arbitrum servers, co-locate, play these latency games, and that's not fun either.
Yeah, I could talk on that, by the way.
Yeah, absolutely. I give the mic back to you. So I believe in a market approach. Like either we have to eliminate these opportunities totally altogether, like with mempool encryption or so on, or we should have a way for users to express their intent, or we should have some ways for market to kick in, like maybe some auction to extract this value and then decide to give it back to users or protocol or whatever. So I want to inject one more thing. There was a recent paper in STOC 2023. STOC is a very theoretical computer science conference, and it was about an impossibility result to do credible sequencing so that you can prove that there is no extraction in the DEX transactions. That was a quite interesting paper for me because it kind of sets the stage for this paradigm that it's even impossible to do MEV resistance or credible sequencing for certain type of transaction. How do you want to stop it when you have all this craziness? So for that reason, I think it's better to go with market here and just decide how do you want to distribute that value.
Yeah. Let me comment on that because it's a really interesting story actually. So when you consider a centralized trusted sequencer, that should be the ideal, like if you consider like an ideal functionality, no MEV, the ideal world. We have a truly trusted system and a truly trusted party that will enforce the first come first serve ordering policy. You would think, oh, that's amazing, it's always going to work. Now, what's interesting in Arbitrum is that you have this setup, but what they also have is something called the sequencer feed. So every 250 milliseconds, the sequencer will form a little block and post it to the world. And the reason for that is, if you're a user, you send a transaction to the sequencer, you look at Etherscan, and you can say, oh, my transaction is confirmed. Pre-confirmation in a sense. Now, what happened with the sequencer feed is, Infura connected to it, Etherscan connected to it, but then MEV bots were like, oh, there's a sequencer feed. I'm going to connect to that. And they were like, oh, I can see the transactions. The most recent transactions that are confirmed. Oh, what if I look at this and backrun them? And so they started backrunning these transactions. Another MEV boss discovered it. Next thing you know, there's 150,000 WebSocket connections of everyone trying to backrun these transactions. So even in this ideal setup, you still have this stupid latency game that emerges because there's still a backrunning opportunity. And so as part of that acknowledgement, again, this sort of like the time boost work was, I hope it's being presented here, I don't know if it is. But what they talk about there is, instead of having this latency game, could you have an MEV auction? Like a very rapid short auction, and in their case, they want to facilitate just backrunning. So you provide a bid for these backrunning opportunities, then those funds could obviously be fed back to wherever they could go to. And I think they'll use the tip in the transaction to do that as well. That's sort of the goal. But that's cool though, because then you're like, well, either you have a latency game or you have an auction. And now maybe you can start plugging these in certain parts where latency games pop up. So that's pretty cool. It's sort of like an acknowledgement that latency games are always going to be around. So you may as well use an auction. But now the question is like, what is the minimal auction that you need?
Yep.
And I think that's a cool question to explore as well.
Also, a sort of fun story on the Starknet side related to this, and it kind of brings home the point that it's really, really hard to prevent MEV or transaction orders, even if you have a scheme to do so. So on Starknet, for a long time we didn't have fees for reverted transactions, and this is because you couldn't prove that those transactions hadn't been included in a valid way, in some sense, right? And a few weeks before they fixed this, some parties got this idea, hold on a second, that means I could trigger a transaction consistently, as fast as possible, trying to extract MEV while doing the computation on-chain, because it's so cheap. So now we had MEV instead of off-chain ordering. They just decided the ordering is, I will be between every transaction by spamming it, and it's pretty smart. And it almost took down the chain. And luckily we had the solution a week or two later, but it just gives you this idea that like the game can always be played somewhere, and if you try to prevent it in one place, it pops up somewhere else. So.
Just adding my point of view in this, I think the way to prevent MEV is every 2 hours we go to every DEX and we make every token value 0. Right. So we talk a lot about MEV, ordering, all the fancy stuff. Now to the real stuff. Users care about rollups because they give them cheap transaction fees. How do rollups do that? And what factors are affecting the fees that the rollup is offering to their users?
Yeah, I think the fees would probably be affected by how much the L1 transaction cost is when you're proposing a block on L1. So in this case, it will be the on the proposer side, it will be like how well you can compress the transactions that are on L2 onto L1 proposed block. And for ZK rollup, when you're proving a block, it's basically how small you can get your proof size to. Yeah.
I'm going to challenge this because I think that's the current narrative for rollups, as you're saying, the real cost is how much it has for L inclusion. But the reality is that, given any supercomputer, I can find you somebody who will fork-bomb that supercomputer to do something useful, right? So it means that at some point, all of the rollups will also be running at maximum capacity, right? And then we'll switch from trying to get L1 inclusion to having a subset of the fee for L1 security, and then the rest is going to be priority fee for trying to enter into the set. And I think to make a broad ecosystem statement, we're a bit naive to think that it's going to stay this way for a short amount of time and not actually very quickly change, especially when you have MEV and ordering and these things involved.
Yeah, I think Keng and Jorik, both of them are right. Like today, the most of cost is the cost of data availability on L1. For us, it's 80%, 85%. The numbers are very similar for other ZK rollups, and we hope that data availability becomes cheaper on L1, but it's not the case today, and maybe it takes 2-3 years for it to become cheaper. Yeah, the way rollups make transaction fee go lower is that they make execution cost small, because the execution happens off-chain, and instead of everybody executing everything, one supercomputer executes everything and makes a proof, and others just verify. That's the gist of it for regular tools. But I do agree with Jorik that in the long term, the cost of generating proofs will be very low. Like it will be the same as execution. Like it would be essentially free. Like if research goes like this. And also data availability technology will be matured. We have data availability sampling. We have with data availability sampling, the more users you have, the cheaper is to expand the capacity of your data availability solution, which is quite amazing. That's what Celestia is proud of too. So data availability also becomes cheaper, and then if we have built something useful, it's going to be used by people, by robots, by everything, and then we only have to pay for priority fee, essentially, like priority of inclusion. Yeah.
Yeah, I'm going to try to take a different way to explain this. I was trying to summarize in my mind the best way to explain this answer. So hopefully I do a good attempt at this. I think before we look at the cost of transactions on the layer 2, we should look at Ethereum first. Work out what is the bottleneck to scalability on Ethereum. And there's 3 resources that you care about. One is execution, state growth, and bandwidth. Now we know execution is just expensive on Ethereum anyway, and the reason for that is when I create a block as a staker, if there's a lot of execution there, I pass it to my peer, he has to replicate this execution before he passes it on. And if there's a lot of execution, it slows down block propagation. And if you slow down block propagation, you won't get blocks every 12 seconds, and then some nodes will fall off the network. So execution is like the bottleneck to getting blocks across the network, and that's limited really, by how big you want your set of stakers to be, who can participate in that process. The next one is state growth. State growth is probably the biggest hurdle to scalability in Ethereum, because it never goes away. You just keep adding to the state. The database gets bigger and bigger and bigger, and it just grows. And that's actually why we basically have the gas limit today. The gas limit is like a proxy to restrict the ability to grow the state. That's like one of the reasons why the gas limit sort of exists today. And really what you're trying to do is, you want to maximize the set of parties who can hold this database and check that the Ethereum is correct. And so we need a small database for that. And so the acknowledgement is that, well, the third resource, bandwidth, it's actually the most abundant resource on the network. How fast can you throw data across this network and then discard it afterwards? That's basically the idea behind bandwidth. And so rollups take advantage of the bandwidth of Ethereum. We post our data to the bandwidth, it ends up on the blockchain, but that can be pruned later on. It doesn't have to be kept around. So that's why we have rollups, because we've acknowledged that bandwidth is the cheapest resource on Ethereum that we can leverage to extend Ethereum security to this off-chain system. But now you're in the rollup world. And right now, today, data is our biggest expense. So even though it's sort of abundant on Ethereum, hopefully long term with all these DA layers and Dank sharding and Celestia and Ava, whatever is going to be popular there. But that is still our biggest cost today for a lot of these rollups, even for the ZK rollups. No, I think data would be, my gut feeling would be data is still more expensive than proving costs. But maybe these guys can talk more about that. Yeah, that would be my gut feeling. Long term, we still have to deal with state growth, and we still have to deal with execution. Yeah, so in that case, the question is, what sort of nodes would you expect in the will you expect in the future who can actually check the validity of this database? Because ultimately, that's what matters. If you're, let's say Arbitrum, because I'm Arbitrum today, I want to make sure people in this room can check that the Arbitrum database is correct at any time. And you have to basically decide that population size, and that will be what ultimately constrains your scalability. So that's sort of a long answer, but I hope it sort of gives an idea of why the transactions are expensive. And there will eventually be a bottleneck of, until there will be eventually congestion on these L2s as well. And then, I guess the question becomes, how many rollups can you glue to Ethereum? And then how many rollups can you glue to these L2s? And hopefully keep passing the buck of this scalability problem.
There is an area of ZK that I don't think anyone's looking at yet that I'd love to see is can I efficiently get a proof that just a transaction or a subset of the database is correct according to the state transition, and that could help reduce the size of the nodes that need to check. I hope that comes along. And then if we have 1 more minute on this, or we have 5 minutes, I'd love to get people's take on how to reduce the data that's required based on. Let me ask my question.
You already have. Or we can move on, your choice.
Say the same question. How do you reduce the amount of data on these
There you
blockchains? Like maybe putting more color on it. What is Celeste doing? What is Dangshan supposed to be doing? What is EigenD innovate? What are they trying to do, and can they actually do it, or is it just?
Right. Actually, I would like to go back to like the state growth things. I think for like ZK rollups, as long as we submit the last proof for the last block, I feel like that's the only proof of the only state that we have to keep in a node to prove the entire blockchain essentially. So it's sort of like a constant state. But in terms of like DA or Celestia and stuff, maybe I can pass that.
Well, the thing in this case is then who is incentivized to give you the data that's in the blockchain, right? Like you may have the proof that the transition is correct, but then you run into the risk that the sequencer who posted doesn't give you the actual data. And then the proposed solution to this, I know in the Starknet world, is to post this data onto 4844 and just say that like only a valid state transition, a state transition is only valid if the data of the state diff is in 4844. And that's a clean solution, but it still doesn't mean that you get to request the entire state because you only get the diffs at any particular point in time. I don't know if it's good enough to trust one person, like to have a one-party assumption that you might be able to get the entire state from somebody, especially if you don't have decentralized sequencing. It means that like this single sequencer isn't actually incentivized to give you the data because they don't need to, and they can also protect their MEV if no one else is able to do the sequencing. I think it becomes very sticky in that.
Yeah, I think Patrick can speak for himself, but I guess when he mentioned when he mentioned state growth, he meant this, not any of this. He meant that when you're running a node, you have to keep the state in the RAM, the whole state in the RAM, because you need random access to a state, and that the state grows. Maybe I make a new account today and I throw it away. Tomorrow I make another account and another account, and I make these states here and there, and everybody else is doing that. And after 100 year, 200 year, we have like terabytes and terabytes of a state that has to be kept in RAM, like at least the way today's full nodes operate. So you can't fit that all in RAM. Obviously, there are software solutions to deal with it, but fundamentally, it has to be solved in other ways. I mean, the way you mentioned it, like transactions with proof could be one way, like, I mean, I could think theoretically that could work, but we don't have any working proposals yet, as far as I know. Is that right?
Yeah, that's exactly it. I can give a fun example of this. So, I used to work in Infura. I mean, I was a researcher. I wasn't very good at SRE. I respect people who do SRE. They're very special people. You have a lot of patience. But one of the problems that popped up that was so when you look at a Go Ethereum node today, one thing people don't realize is if you consider Ethereum as a database, you actually have to keep around like 128 different copies of this database. So every block has a new database. You have to keep that around for reorg safety. So you can quickly reorg, deal with it, and then move on. And Rollups will probably have to do, give or take, well, it won't be the same, extreme of that, but you may need to keep around with some of them, or hopefully just one, ideally. But what's interesting in the Polygon case, because Polygon also does use Go Ethereum in the most part, and they all have the same issue. At one point, their memory was growing 2 megabytes every second. And I don't know if that sounds like a lot, but at one point it was getting like 15 terabytes. And the SRE engineers are like, this isn't going to fit on Amazon anymore. Like, what do we do with this? This is like a real legit problem, But just going back to the original question, there's 3 parts to it. So the one is, how does Ethereum keep the data around for a while? That's like the DA layers. And generally, maybe just to sprinkle magic dust around it because they're very hard to explain. It's a bit like saying, can you take the database, split up in little fragments, throw the fragments out there, and then randomly sample that I can retrieve them all if I need to. So if you're like a node in the network, you hold one fragment, you hold another fragment, you hold maybe the same fragment over there. We just like randomly sample and say, okay, I can probably get the whole database. It's probably out there. The next one is the layer 2, or the rollup has to send data to Ethereum to, as a way to broadcast an update to the database so anyone can get a copy of the latest database. That could be the list of transactions, it might be a state diff. There's like, actually those are 2 approaches right now. And what we're really missing is like a comparison of how well they work in practice. Like, are you better off posting a list of transactions? Is the state diff more efficient? Or do you want a combination of both? That's interesting. And the third one is, how do these L2s reduce the size of their database? Because you don't want to keep around like you don't want to keep around an account balance from 10 years ago. Maybe you could expire that somehow. And in 2017, like Ethereum had a whole range of research on state expiry, state rental. A lot of those schemes can pop up where maybe I could expire data after a year, but if you really want that data, you could prove to me that wasn't the database a year ago and it should be reinstantiated. And you can do cool stuff like that now. But I think that part is probably 1 or 2 years away from people really exploring. Because it is going to be a problem, but I don't think it's the most immediate problem in everyone's mind.
I can add something about that. There is a real world example of the scenario that Patrick is describing. Binance a smart chain. They took gas. They just reduced the limits. Like instead of 30 million gas per block, they had higher gas limit, and they were running roughly a centralized operation, like maybe 6 nodes in total. So they could deal with the block propagation delay as well. And the first thing they encountered was this state growth problem. And we have a real world example that this happens. So we have to be careful for that. But the state expiry, state rentals, all those things are nice, but create a new UX that maybe is not appealing. About data availability, so I had a talk yesterday in L2 days. If anybody is interested, I encourage you to go see that because I put a lot of effort into that one. But yeah, the short answer is the way data availability layers work is that using this data availability test, because we can't make data availability proofs or data unavailability fraud proofs. Fundamentally, that's impossible. So the way it works is that at the consensus level, the consensus clients have to make data availability tests. This could be a naive test, meaning they download the whole data, or this could be an efficient test. They just sample the data. But regardless, that's what's happening in the data availability solutions. So we need to make these tests more efficient. That's the goal. And full dunk sharding will try to do that, and Celestia and others like Eigenlayer, they have different ways to make this test more efficient. But other than that, what rollups can do is compress their data before submitting to L1. As Patrick mentioned, you could just submit a state diff, or I don't know, Arbitrum is using broadly a compression algorithm, a generated compression algorithm to compress the data and then submit it. It gives you like a 3x, 4x compression gain. Optimism is using something else, ZSTD. We are looking into doing one of these generic algorithms in combination to specialized tricks like mapping addresses to indices and removing signatures and so on. But yeah, the problem for ZK rollups is that you have to do the decompression in circuit, and that's going to be a tricky feast because compression algorithms usually operate on this like Hoffman trees, and they jump around in the state, and that's quite complex to do in circuits. But we are trying to do it with a rollup, with a lookup-based approach, and yeah.
I know we're out of time, but data risk compression is not going to work that well because at some point the node operators are going to realize that they're getting compressed data and they're trying to put it in already compressed databases. And it tends to be that compression of compression doesn't actually give you that much, so they're going to bump the price. And a fun fact, we're working on the compression in Starks at the moment with Cairo, so that'll be coming soon.
We'll talk later.
Cool. I think that brings us to the end of our panel. But I'll give you guys like last closing sentences, and like, you can only have 26 words in your sentences.
What do I say? Base boosted rollups. Go check it out.
I'm going to say something similar. If you want to have some fun, come design in the rollup space. There's so much to do. So please join us.
Just in the limit.
Thanks for listening. Peace.
I think the most important thing to remember for rollups is that we're building a technology to protect users and customers from system operators.
Just
Cool, thank you. See you guys around.